Okay, today's lesson is 10.10 part 2, trig functions. We're going to specifically look at the properties of trig functions, including amplitude, period, and phase shift, and horizontal shift, which is phase shift, and vertical shift. So start with this right here. We need to graph y equals sine x, and then graph y equals 3 sine x, and find out how that 3 affects it. So as you can see, here it is. In green, we have the regular sine curve with the maximum value of 1, the minimum value of -1. Now the 3 actually increases the maximum value to +3 and decreases the minimum value to -3. Okay, let's take a look at cosine of x. So cosine of x actually at the origin passes through the point 1. Okay, so in the purple, we're looking at the original function cosine x. It goes up like this, then it goes down to -1 at pi, then back up to 1 at 2 pi. Okay, now the coefficient of 2 in front of the x actually compresses cosine so that instead of one valley between 0 and 2 pi, you have 2 valleys, right? So keeping that in mind, we will define that later as a property of trig functions. And finally, we're going to see what the effect of cosine of x minus pi over 2 has on cosine of x. So the original function cosine x is in green, and in purple is cosine of x minus pi over 2. If you notice, everything has been shifted to the right this many units, and this length right here is pi over 2. So it actually shifts it to the right pi over 2 units. Okay, this right here is the general formula for the equation of a trigonometric function. We have y equals a sine of bx plus c inside parentheses plus d at the very end. Now the a represents the amplitude, and the amplitude is always positive because it is the absolute value of a. And as you can see, a is half the distance from the maximum y value to the minimum y value. You could also represent that by drawing the midline here and then counting how many units up to the very top, the maximum value, or counting how many units to the lowest value, the minimum value. That's the amplitude. Next we have the period. The period is just like we saw with the previous example, or actually the one before that, is that the period, normally the default is 2 pi. But if you have a number in front of the variable, the coefficient, you actually divide 2 pi by b. So the only formula you have to remember is 2 pi over b. This is the length of one complete cycle of the graph, 2 pi over b. That's the period. Right, next we have phase shift. Phase shift is just a fancy word for a horizontal shift or horizontal translation. If it's positive, you go to the left c units. If it's negative, you go to the right c units. And finally, we have vertical shift, which you are used to. It raises the entire graph up d units or down d units, depending on if it's positive or negative. So let's take a look to see how these questions may be asked on the Regents. So what is the amplitude of this graph? So looking at this, let's go ahead and draw this line out. The midline happens right about, oh, that's too thick. Let's try that again. The midline happens right about here. Okay, now if you count, it's 1, 2, 3, 4 units above, and 1, 2, 3, 4 units below the midline in order to get to the maximum point and the minimum point. Another way you could have done it is just subtracted 2 minus -6 to get 8, and then divide that by 2, 4 is the amplitude. You do number 2. This one, what is the amplitude of this equation? Believe it or not, it's as easy as just looking at the equation. Because amplitude is the coefficient of the trig function, it's 4. Amplitude is the absolute value of A, so it's 4. Right? And actually this goes with this because, as you can see, this has the same amplitude, and minus 2 means that it's been shifted down 2 units, and that's why the midline, instead of being on the x-axis, is down 2 units. Number 3, what is the amplitude of the graph of y equals 1/2 sine 2x? Just like you thought, the amplitude is 1/2. What is the period of the function y equals 5 sine 3x? Well, the period is 2 pi over b. b has to be recognized as the coefficient of the variable. So here it's 3. So b equals 3, 2 pi over 3 is 2 pi over 3. Very easy. Number 5, what is the period of y equals sine 2x? 2 pi over 2 reduces down to pi. The period is pi. Number 6, this one is a little trickier because you have to recognize that there's an invisible 1 associated with the variable x, but there's also a denominator of 3. And that gives us 1/3 as b. And when you put that into the formula, 2 pi over 1/3, you have to keep change flip. 2 pi times 3 is 6 pi. Number 7, what is the period of -10 sine pi thirds t? You have to recognize that pi over 3 is a number. Pi is a number 3, the number, so that there's your fraction. And this is the coefficient of t. Therefore, this is b. b equals pi over 3. 2 pi over b, 2 pi over 3. The answer is 6. Because as you can see, pi's cancel out. All right, number 8, describe the phase shift. So here you have to remember that because we have minus pi over 4 units, this is inside the parentheses, minus pi over 4 units, we're actually going to shift to the right pi over 4 units. So this is what the graph looks like. The original one is the dotted line, that's sine x, and then sine x minus pi over 4 shifts to the right pi over 4 units. Describe the phase shift of 3 cosine parentheses x plus pi close parentheses. Because we have plus pi, we're actually going to the left 3 units. And also notice that the amplitude is 3, so this also sort of stretched it to reach 3 and -3 there. So to describe this phase shift, it is pi units to the left. Good luck to you.